series of lessons on flight controls is to describe the various primary and secondary flight controls that are available to you, the pilot, and to explain the mechanics of how the pilot's flight deck inputs cause the controls to move. The aerodynamic reasons why flight controls have the effect that they have on the aircraft is outside the scope of these lessons. We will only touch on the theory here when it is necessary for reasons of clarity. In this first introductory lesson, we will look at how an aeroplane moves around its axes. For steady flight, the aircraft must be in a state of balance, with zero moments around its axes. The primary flight controls are designed to enable this to be achieved for all possible configurations and centre of gravity positions. The controls are also required to manoeuvre the aircraft around its three axes. The three axes about which an aeroplane rotates are the lateral axis, the longitudinal axis, and the normal axis. The movement around an axis is produced by changing the aerodynamic force on the appropriate aerofoil, wing, tail, or fin, and this may be done by changing the camber of the aerofoil by deflecting a control surface, changing the angle of attack or incidence of the aerofoil, or decreasing the aerodynamic force by spoiling the airflow. The most common method used is to change the camber of the aerofoil. This is done by deflecting a control surface on the trailing edge of the aerofoil, either up, decreasing the camber and the amount of aerodynamic force generated, or down, increasing the camber and the amount of force generated. This principle can be applied to control about each of the axes. The aircraft rolls about its longitudinal axis. The devices most commonly used to control roll are the ailerons. The ailerons are operated by rotating the control wheel or yoke, or by moving the control column or stick laterally. Rotating the control wheel clockwise will cause the left aileron to move down and the right aileron to move up. The aircraft will bank to the right. Counterclockwise rotation of the control wheel will have the opposite effect. That is, the aircraft will bank to the left. The aircraft pitches about its lateral axis. Pitch control is most commonly achieved by the use of elevators. The elevators are controlled by moving the control wheel or control column fore and aft. Pushing the control wheel forward lowers the elevator and the aircraft pitches down. Pulling back on the control wheel raises the elevator and the aircraft pitches up. The aircraft yaws about its normal axis. Control in yaw is normally achieved by the use of a rudder. The rudder is controlled by the rudder pedals. Pushing the left pedal forward causes the rudder to move to the left, and the aircraft nose to yaw left. Pushing the right pedal forward causes the rudder to move to the right, and the aircraft nose to yaw right. The ailerons, elevators, and rudder are known as the primary flight controls. That is the end of this introductory lesson. You now know that ailerons control the roll of the aircraft about its longitudinal axis, that elevators control the aircraft's pitch about its lateral axis,